record for our friends that aren't here with us right now. All right. So 15th term, or just generally, what do you see as this pattern for how many squares are in the term? So here's our term number and our squares. All right, how about our first term? How many squares are in our first term?
1.
Yeah, 1, thanks. How many squares are in our second term?
4.
4. And how many terms are in our third? How many squares are in our third term?
9.
9. All right, so we could keep going and go all the way to 15, but I'm hoping someone has already seen what is going on here with this pattern. Does anybody have an idea of what, if I skipped all the way down to 15, what would I come up with for my answer?
I think I know what it is, but
There's something special going on here. And I'll give you a hint that it's in the shape here. What's special about the shape of each of these terms in our pattern?
would next one be 16?
The next one would be 16. Joe, how'd you come up with that?
So the first one is like, the first term is 1 square, and then the next one is 4, so 1 plus 3 is 4.
Okay.
So it's plus 3, and then the next one is plus 5.
Plus 5. So the next one would be
Next one plus 7.
plus 7.
By odd numbers.
Okay. So that is a really important observation there, that we have plus 3, plus 5, plus 7. And we could keep going all the way down to 15. I'm hoping somebody out there has seen a shortcut. Joe's pattern is going to be important for determining if it's linear, quadratic, or exponential. But does anybody see a shortcut here? What's special about the numbers 1, 4, 9, 16? Those are a special set of numbers that we've learned about this year.
Oh.
Maybe I'm gonna put the next one in, and maybe the next one will help you see. Let me erase that. Maybe if we put that next one in, if we put 5 in there, Joe, what would I add next? What would we put in there? What would we have to add?
Oh, you would add 9, my bad.
We would add 9.
Yeah.
Okay, so someone other than Joe, what would the 5th term be? Good morning, Jamarian. David, what you got?
Okay.
It'd be
What did you
25.
25? Oh, yeah, someone's on the chat here. Let's see. Oh, hello.
Java says hello.
Javo says hello. All right, 25. Okay, maybe that 25 will help. What is special about the numbers 1?
Oh, wait. Okay, I think I got it. So it's like the term number times itself.
The term number.
Oh, that's so easy. Oh
itself, right?
Yeah.
These are those special set of numbers. This is 1 squared, 2 squared, squared, 3 squared, 4 squared, 5 squared. And you can see that in this shape, this is a square. I don't really need to color that in. That is a square. And so, yeah, these are called the square numbers. So if I want to do 15, how many are in the 15th for part A? Someone other than Joe? What would I need to do if I wanted to figure out the 15th term? Z, what would I do to figure out the 15th term?
Oh.
What do you think?
What?
Z, are you there, man? Did we lose you? I think Z's gone. All right. Z is no longer with us. All right. How about you, Xavier? What do you think? For the 15th term, what would I need to do? to figure it out?
Well, you would add 2 each time.
Yeah.
15th term would be 225.
Hey, Joe.
Sorry.
Yeah, so Xavier, I could keep doing that +2 pattern and go all the way down to 15. That is true. That is the pattern we're seeing there. And then the shortcut, Joe, now that you've chimed in, Joe, what is the shortcut here?
You just multiply 15 times 15.
15 times 15. All right, 225. So because these numbers are the square numbers, if we're looking for the 15th term, if we want to cut to the 15th term, we're going to do 15 squared. Just like 25 is 5 squared, and 16 is 4 squared, and so on. Okay, so Henry, do you think this pattern is linear, exponential, or quadratic?
Quadratic.
Oh, yes, sir. How'd you know? Nice job, Henry.
Because it has the it goes out 3 times, you could say, I guess.
Do you remember what those things are, what that's called? I know what you're talking about right now.
No, I do not remember.
Who remembers what these green +2s are called whenever you have the first pattern?
Second differences.
Oh, Joe is on fire tonight.
You mean this morning?
I don't know what day it is. I don't know what time it is. It's all the same, Henry. All right. The second differences are the same. Okay, the second differences are the same, which is an indication that we have a quadratic pattern. All right, and last one, the equation. Well, if I am doing the term number times itself every time, term number times itself is n squared.
That's it. Oh, right. That's easy.
You could also say what? If you didn't want to do n squared, you could also do
X squared.
x squared if you prefer the
2n.
variable. Not okay. That's what I'm looking for. Is it 2n? Is 2n the same as n squared?
No.
No.
Damn.
What, Joe? Language. Careful. N squared is the same as what? So Joe threw out the idea of 2n, and he's on to something, but it's not 2n. N squared is the same as what? Anybody else out there? Java, where are you? I don't even see you on the screen right now. Have you disappeared on me? N squared is the same as n times n.
Oh.
N times n and n squared are equivalent, whereas 2n is the same as n plus n. Okay, and that's not what we have in this case. But 2n is equal to n plus n. All right. All right, so our good old patterns. We will have to do another pattern next Monday. All right, next one. All right, are these equal? Are these equal? We've got x is equal to the quantity -3 squared plus 1, and y is equal to the opposite of 3 squared plus 1. Are these two things equal? So I'm going to go with, who do we got here? Someone other than Joe. Joe, you may not chime in on this problem. You did an awesome job on problem 1.
All right.
All right, so what do we think about this problem? Are they equal? I just want you to type in the chat. Type in the chat, yes or no. Are they equal? That's how I'm going to know people are here, and how I know people are not, didn't just put their computers on and bounce. So if I see and Joe, you can chime in on the chat. I want you to just type yes or no. Do you think they're equal? Henry thinks yes. David thinks no. Owen's a yes. Luke's a yes. Poe's a yes. We're waiting for Robbie. Robbie's a yes. And we need Xavier and Z. who may have left the building. Xavier's in the building. All right, Z, you're my last one. Are you still here? And Javo, I don't have an answer from you.
He just got back.
Did you just get back? I can't see him on my screen right now. Jamarian, you got to type in the chat if you think those are equal, yes or no. I'm waiting on you and Zambor. All right, well, let's take a look. This thing here means -3 times -3.
So I was right.
I don't
Oh,
know.
no, I messed up. Oops.
Well, we'll see, David. -3 times -3. And what does -3 times -3 give us, David?
+9,
+9 plus 1,
which is
which is 10.
x equals 10.
X equals 10 on here. Now on this second guy, this is the one that you guys just don't believe here.
It's negative what? Oh,
It's -3 times 3. It is not -3 times -3.
Oh,
I
was
knew
right.
it. I knew it.
Plus 1. David, you are right. They are not equal. David, what is y equal, David?
What?
-8.
What is y equal?
Yeah.
Sorry, I didn't hear you.
Y equals -8.
-8, yeah. There you go. All right. So remembering that if you are squaring a negative number, that negative number would be in a parenthesis to say, I am squaring this whole thing. Whereas this thing means -3 times 3. That does not, it means the opposite of 3 squared. It does not mean -3 times -3. All right, so that's another one of those concepts that we've talked a lot about this year. I just want to review. All right, last one. Name 3 solutions to this equation. So I'm looking for anyone, just type in a number you think makes this true. Oh, come on, Poe. Really? All right. Type in a number under 10 that makes this true.
Are we just guessing or what?
Oh, you don't have to guess. So Poe says 2. Let's see. 5 times 2 plus 10. Is that equal to 5 times 2 plus 2? Poe, what do both sides equal? This gives me 10 plus 10. This gives me 5 times 4, so 20 equals 20. So Poe says 2 and 2 works. He's right. Does Owen says 4. All right, let's do, I need a different, just so they don't get confusing. Let's do 5 times 4 plus 10 is equal to 5 times 4 plus 2. What does Owen get on both sides? What does he get here on both sides of this equation? Anyone can type it in. If we plug 4 into that equation, what do we get on both sides of the equation? $30. Thank you, Jamarian. All right, he is 30 equals 30. So x equals 4 is also a solution. Why do both 2 and 4 work?
They're even numbers, I think.
Okay, they're both even. Should we try an odd?
Sure, yeah.
Yeah, let's try an odd. What's your favorite odd number, David, that's under 20? Let's go under 10. 17. 17's kind of
Let's go
annoying.
with 3. Let's go with 3.
Let's go with 3. All right. Let's do 3. I'll do 3 in green. We have 5 times 3 plus 10 is equal to 5 times 3 plus 2. 15 plus 10 equal to 5 times 5. Are we good?
Yeah.
Yeah. They both equal what? Or are they both equal? Yeah, Jamarian, you're right. And I'm going to get to that in a second. What happens on both sides? What do both sides of this equation equal?
25.
25. Okay. So x equals 3. So Jamarian says in the chat here that all numbers work, and that's true. Yeah, in this case, if I distributed here, 5x plus 10 equals, if I distribute, we have 5x plus 10. So we have one of these identities, and so anything works. So is there any number that doesn't work?
No.
No. Anything's going to work here. All right, all numbers work. Who just joined us? All numbers work here, and that's an important thing to know. A lot of the equations we saw, who is this? Who's Kells?
Raquel.
Is it? Okay.
Yeah.
I haven't seen him call himself Kells before. Raquel, is that you? Before I kick this rando out?
Yeah.
Okay.
Hey, check on that thing.
Yeah, we'll do that in a second. All right. So in this case, we don't have a number that's not a solution. All numbers work. And I picked this problem today because we're going to talk more about inequalities. And we're going to talk about inequalities and solutions to inequalities. So in order to understand solutions to inequalities, I want to make sure we understand what a solution to an equation is. So a solution to an equation is any number that makes the equation work. All right, and so that's what we have right here. We have a number that makes it work. And in this case, we have all numbers make it work. Okay, so when you have a case where all numbers make it work, then that's where we say all real numbers. Name a number that's not a solution. There isn't one. Anything that we've talked about, all real numbers will make it work. Okay, so today, let's get into, I'll do business and then I'll talk about what we're gonna do in class today. So first thing is that your extra credit projects were due yesterday. All right, I did see a few submissions on the extra credit project, so I'm really excited to watch those. I will be grading these projects over the weekend, maybe Friday. I'm gonna have a lot of time on Friday to do some of this work. So you'll look for grade updates on Friday or Saturday. Test corrections, for those of you that wanted to do test corrections, they are due today. I did one test correction with one student, and there are some of you, I think 2 of you reached out to Miss Downs to do yours. So if you want to do test corrections, they need to be done today. The Desmos that we started in class on Monday, you needed to finish that, okay? We're gonna check a little bit of that out. Some people think they're all right, but they're not. So we'll see how people are doing on that. Can we do test corrections? Yeah, talk to me after class, Jamarian, and we can take a look. And then the rest of this week, so once we have class today, and then the only thing you have left to do is a Delta Math assignment, part 2 of inequalities. So you guys did part 1 on Delta Math that was due yesterday at 5. And then part 2 is due Friday. Now, David, this morning, he was the first one on, and he was asking about part 2. And we're actually going to learn how to do part 2 today in class. So some of you I saw took a look at it already, and I could see you got a lot of them wrong. So that's what our lesson's about today, is part 2. Yeah, Jamarian, I saw that you did it. All right. So we're going to work on part 2 today in class. So before we do that, I want to dive into the Desmos activity just briefly, just so people can see how they're doing on this Desmos activity. So, oh, Joe did part 2 already. Well, good. Well, Joe, you'll still learn something hopefully here. Oh, before we do that, I need everyone just for a moment to turn on their camera because I need to take a picture for the yearbook of our class. So I need everyone to turn on their cameras. There's Owen, Robbie, Henry, Poe. Looking good, Poe. You're looking good. Zambor, where are you? David. David, does your camera work?
What?
Can you turn on your camera, please? I need to take a class photo for the yearbook. Xavier, can you turn on your camera? Rock, good morning. It's so good to see your face. Hi. Oh, why? Because this is an interesting situation of learning. Xavier, can you turn on your camera?
It's not working right now. It'll probably take me a second.
Okay.
Come on. All right.
Oh, there's David. Good morning, David. This is the only place you can wear a hat in class. All right. All right. And our two soccer guys, Soundboard and Xavier. All right. Here we go. I'm going to do this. You ready? Everyone smile. 1, David, 2, 3. Nice job, everybody. All right. Xavier, if your camera comes on, we'll redo it. Oh, who just walked in? Who is this? Xavier. Oh, Xavier.
It like kicked me out when I turned my camera on for some reason.
Oh, okay.
Why is it so dark?
Xavier, are you okay, man? You have lights in your house? All right.
Yeah.
That looks cool. All right. All right, everyone turn their camera back on. We got Xavier now. You gotta,
Oh my.
I
God.
know. That's tough. David, come on back. Poe. All right. All right. David, where are you, man? David. Come on, David. Turn your camera on. I wish I could turn it on. Xavier, I can't see your face. David Fofana will start his video later. All right. There he is. Joe, come on. We're almost there, man. All right. Joe had to be the punk. All right. Here we go. Ready? Everyone smile. 1, 2, 3. All right. Good job, everybody. Okay. Back to our lesson. So I wanted to get into this Desmos activity and take a look at how people were doing with that slide 11 and slide 15. So I'm going to share what I see right now on these two slides so people can understand how they're doing. So like David, I can see that you started this. Poe, you are looking good. Amir's looking good. Jamarion's looking good. Joe, Owen, Jack, Luke, you're fine. These are the 2 leftover cards. So you're fine. Joe, you have 1 set you need to fix. 1 set of 3 is off. Okay?
I did it twice though.
You did it twice? Joe.
Yeah,
Oh,
'cause-
yeah, I do see that now.
The
Oh.
first time I did it, and then yeah, I got tired.
Oh, you could have just fixed your old one. That's okay.
Okay.
So maybe Joe, when I emailed you back last night, I didn't realize you did it twice when I was looking at slide 15. All right. So for those of you who haven't done this yet, I'm actually going to go to slide 15 and take a look. Oh, Joe, now I see it down there. Okay.
Yeah.
Okay. So please just make sure you are matching up these cards. When you see this, if you're struggling with this, I would say it out loud. I would say for something like this one, X is less than 1. Should this be an open circle or closed circle on this X is less than 1? Is this open or closed?
Open.
Open. Okay, this is an open circle. So I am looking for
It's
this
that.
guy
Yeah.
here. All right, and they need to lock together. All right, so this is an open circle and everything is less than 1. Whereas with this guy, someone other than Joe, how would I say this guy here? X is what? X is
Greater than.
or
Equal to.
equal to -2. So I'm looking for a closed circle and at -2 and then everything above it. So I'm going to lock this guy in.
All right.
Okay, so that was the activity last night. All right, so some of you started it but did not finish it. And I'll be honest with you, I'm just going to look at cards 11 and 15. So if you have 11 and 15, you're good to go. All right, it was all building up to 11 and 15. All right, so those are the two cards I'll be looking at for that activity. Would anybody like to ask any questions about this activity before I have someone in the chat? That you can't jug me. Okay, well, I still can. I don't know what it would do, but all right. So, all right. Anything else on this activity? All right. Great. Then I would like to talk about we'll talk about the new part. So this is where we're diving into part 2 of inequalities. Oh, my screen is loading. There we go. All right. So this is the new part. This is today's work. We're going to talk about solutions to inequalities. All right. And this, just like a solution to an equation makes an equation true, a solution to an inequality makes an inequality true. Let me mute people because I can hear myself. I'm just going to mute all you guys. And if you need to ask a question, feel free to unmute yourself. But otherwise, keep yourself muted because I'm hearing feedback. All right. So a solution to an inequality is a value that makes the inequality true. So when I'm looking at example 1, if someone could unmute themselves and tell me, how do we say this thing right here? How do I say that? Or you could type it.
N is equal to or less than 4.
Equal to or less than 4. Thanks, Rack. All right, n is equal to or less than 4. All right, some of you say less than or equal to, it doesn't matter. But the point is that we're talking about things that are less or equal to. So in this case, and again, you can type it or you can say it. Which of these values would make this true? 1, 2, 3, 4, and or 5. There can be more than one.
V.
V.
IV.
IV.
Yeah. Oh wait, and 4.
And 4. N equals 4. Because it's less than or equal to.
Yeah, also 3.
Also 3.
It's 2.
All right, so all of these things make it true. And I would represent that by putting those points on there and then everything else that's less than. So that was the Desmos activity, was looking at some of these graphs. All right, so we've got this closed circle at 4 and then everything behind it. All right, and I just want to remind people that if we have an open circle, we would use open circle for greater than or less than, and closed circles are when you have the equal to parts, okay? Because closed circle means it includes that point, so less than or equal to. All right, so if you didn't write this down, okay, remember, and this is true for this class and all of your classes, if you're on these live Zooms and the teacher is, going through a definition, make sure you're writing it down for yourself and trying these problems at home. Watching, okay, is not being an active learner. So make sure that you're actually writing these things down. And these slides are always available to you on our fundamentals Google Doc. All right. Okay, so here is an example from tonight's homework. All right, this is one of the pieces of the Delta Math. It says, which of the following values are solutions to the inequality -3 is less than 4x plus 6? And it's going to give you 3 choices. So what you're going to do, or who thinks they know, Javo already says 3. Who thinks they know what to do here? Like if you were going to approach this problem, how would you do it? What would you start with? Javo also says 1. How are you coming up? Luke thinks he did this yesterday, which is awesome if you did it. For those that didn't do it, though, I'm gonna teach you guys how to do it. Henry, how would you start this problem? What would you do?
First thing that I would do is I would subtract 6 from 3. So it would be -3 plus -6. That would get us -9. Then you
Okay.
have 4x is greater than -9.
Okay, so Henry wants to move this 6. That was not the way I was going to do it this time around, but that works. That is a good way to do it. I'm going to say Henry's way down here. So he's got -9 is less than 4x. And then what would you do, Henry?
Then I would wait, then you would divide 4 from 9.
Okay.
-9, sorry.
So we have
So
-9/4 is less than x. Okay.
You would get whatever that equals. That would
What?
be x.
What does -9/4 equal as a mixed number or a decimal? -9/4.
I don't know.
Yeah, anyone can chime in here. -9/4.
Would it be 2 1/4?
Yeah. Mm-hmm. -2 1/4 is less than x. So if you do it Henry's way, which is one way you could do it, that's fine. Henry gets this solution, -2 1/4 is less than x. So at this point, he could say, well, if 2 1/4 is less than 5, so 5 works, which Jamarian said in the chat up there. He said 1. -9, -2 1/4 is less than 9. That's not true. And then -2 1/4 is less than 1. That's true. So that's one way you could do this problem. And then you would go down here and say, well, 1 and 3. So I would pick this guy here. Okay. The way I was thinking about this as we first start out this process of just thinking about solutions is you could plug in the number. So I'm going to do this just for 5. I could say -3 is less than 4 times 5 plus 6. So I took the 5 and I put it in for x. So I have -3 is less than 20 plus 6. So -3 is less than 26. And that's true. So I'd say, oh yeah, that one works. And then you go to -9, and when you did the math on -9, you'd find, oh, that one does not work. Okay. So you could do it Henry's way, or you could do it my way. Both are good ways to do this problem. Maybe you have a different way that I haven't even thought of yet. Okay. But this is the first part of the Delta math is I think I put 5 problems up. You have to go through and try the different numbers and see, does this work or does this not work? All right. And that is just the idea of thinking about solutions. Solutions are numbers that make it true. Numbers that make it true. So when you plug those numbers in, it's good practice too on some of your positive and negative work. Would anybody like to ask any questions on this? 5 minutes. Thanks, Henry. All right. All right. Well, from here, I'm going to skip this part. If you want to do some extra practice, you can kind of go through these on your own time. But I do want to get to this part where you're actually going to solve inequalities and show you how to do it on Delta Math. Because the Delta Math, you have to do some dragging, which is a new thing. All right, so on this problem, we're going to use the same rules as we did on when we solved equations. There is one exception to that rule, and that's what we're going to explore on Monday. All right, so the problems you're going to do tonight don't have that exception to the rule, but there is something special going on with these inequalities that we'll explore on Monday. So just like Henry did on the last problem where he just solved the problem, you're going to do the same thing here. I'm going to take a look at x plus 5 is greater than 2. What would you do to both sides here? If you're doing the problem x plus 5, if this was just good old x plus 5 equals 2, what would you do to both sides? You can type it or say it.
I think I have it.
Okay, go for it.
You would subtract 5 from both sides.
Yeah, you're going to subtract 5 from both sides. So we have x is greater than -3. So on my number line, I'm going to put -3 in the middle, and I'm going to put -4 behind it. If we were in class and you had to write these, I would make you put at least 3 numbers on your number line. But Delta Math, you're not going to have to worry about that. But I do want you to have a sense of your number line. Would this be an open or closed circle?
Open.
Open, thank you. This is an open circle because it's just greater than. So I put an open circle at -3. It's a little big and dramatic. And then I would do everything greater. I would color in my number line with everything greater. And so that is what your solution, because then you cover all the solutions. -2 is greater, -1, 0, 2,000, 1 million. It goes all the way to the end. Okay? Thanks, guys, for chiming in on the chat there. All right, so I want to do one problem on Delta Math with you to show you so you understand how to use the feature of dragging the number line. So we'll do one of these together. For those of you who have done it already, awesome. But for those of you who are still going to do it, this will be helpful for you to understand how to use that feature. So here's my Delta Math problem. And unfortunately, I can't write on my computer screen. I should have pulled this up on my iPad. So if you were solving this problem, what would be the first thing you would do? You have -15 plus 6x is less than -27. So what would you do first?
Circle.
Let's
Do
solve it
positive
first.
15 to both sides.
Yeah, we would add 15 to both sides. Good. So now we have 6x is less than, if I have -27 plus 15, what does that give me? -27 plus 15.
-12.
-12, thank you. So now I have 6x is less than -12. And what would I do from there? 6x is less than -12. What would you do to both sides?
Divide both sides by 6.
Good. And I end up with x is less than -2. So on here, I type in x is less than -2. If you need a less than or equal to or a greater than or equal to, you use these. We're not using this or button. That will be used later on with inequalities. You don't need that button yet, but you do need these 2 buttons here. So I'm going to go and I'm going to click at -2, and then I drag it. Oh, I'm going the wrong way. Drag it. Now, I wanted an open circle. So you'll see it says click closed circle to change to open circle. So I just click it and it changes to an open circle. Okay. If you mess up, you can just click it and it'll delete the whole thing for you. So I click and then I submit. It'll say, are you sure? And I say yes, and then you'll see it, you're good to go. Okay. But this number line part, you just got to click and drag, and that's how you put those solutions on there. All right, 10:16, Henry. I'm sorry. Did Henry already bounce or is he still here? I can't tell. All right.
I am still here, but I
Thanks.
was gonna put 10:15, but that was too rude.
Oh, I appreciate it. All right. So that is it for today. If anyone wants to stay on and go ask any other questions or go over anything else, I'd be happy to go over that. But otherwise, you are free to go, and I'll see you guys next Monday. Do your Delta math tonight. All right. All right. Jamarian, you wanted to do test corrections? Okay.
Can I make?
What's up?
I still need help on the true delta math. The part one and the part